Hello, we're back. So in this lecture, we're going to talk a little bit on a deeper, more detailed level about how data is organized and managed. We'll continue to discuss data mapping, and we'll talk about data warehousing and other topics. And again, in our earlier slide that we talked about mapping cholera to SNOMED, there are different types of relationships. The earlier example, we had an exact match, but we could have things that don't match. Like, for example, if we were to map ICD-10-CM codes for hyperplastic thyroid cancer to ICDO, hyperplastic thyroid cancer, there is no exact match. We have some approximate matches, though, right? So a code concept that exists in one coding system, say like ICDO, it has a connection. It's still thyroid cancer, but it's not exactly the same thing as you can see here. Let's talk about data warehousing versus data warehouse, another term that people kind of scramble a little bit. Data warehousing is a verb. It's the actual process of collecting the data from different data sources and storing it in a single database where we can use it for decision making. We use this at Kaiser Permanente, where we would get different data sets from different regions and store them in one data warehouse. So we could use this to see if it would be worth it to do a multi-site study on a certain health services research topic. What the data warehousing creates is the database that makes it possible that exists in these different databases in the different regions, and then we can run one query that covers all these regions. Now we're going to talk a little bit about information governance. And basically, this is an organized wide framework. I like to think of it as a set of rules for managing information throughout its life cycle. And it covers strategy, operations, regulatory, legal, risk management, and environmental requirements. It's basically what rules are we going to use to manage our information. Information governance runs on a few types of assumptions. First of all, we have to look at information as a valued strategic asset. And that's where you hear the term business intelligence. That's what that's coming in. So with every situation that we have in healthcare, something that I've seen used in several different healthcare organizations is the SABRE. And this is typically represented in a four-part PowerPoint slide where they discuss the situation, the background, the assessment, and the recommendation, right? So to make those meaningful information, make those decisions for these situations in order to work our way through the situation, the background, the assessment, the recommendation, we need accurate, reliable information. And that's where the term enterprise information management. So we're not just talking about a single department or a single site, we're talking about the whole organization. The American Health Information Management Association has information governance principles, and these include accountability, transparency, integrity, protection, compliance, availability, retention, and disposition. One of the things with electronic health systems that people sometimes forget about is how do we ensure that if these systems are no longer need data, that it's being disposed of properly, right? There's a lot of interest in AI coding and reimbursement systems, but once that information, say one vendor I know of is using Amazon Web Services, where does the information go? Who has it? All these things fall under the umbrella of information governance. Now we're getting into the topic of data stewardship. This is related to information governance. And it's basically the responsibility for data through principles and practices that ensure that appropriate knowledge and use of data from personal health information is being used appropriately, right? So in other words, who is the responsible department or person for this? Data sharing. Again, even in organizations like Stanford and Kaiser, where people are seen from cradle to grave in them, we always have people that go outside the organization. In fact, the vast majority of them do. So to share this information, we need to be able to collect it, decide what's appropriate to share, and share it. And this is where data integrity comes in. So, in other words, if we're sharing data with another organization, how do we know who's going to be using it and for what purpose on the other end, right? And how do we know that the right information is going to be mapped to the right patient on the other end, right? All these things are part of the greater umbrella of data integrity. And this is where the standards developments comes in, right? So we have organizations like HL7, we have the Digital Imaging Communication in Medicine, the National Council for Prescription Drug Programs, the Institute of Electrical and Electronics Engineers. All these people are creating or adhering to standards that are developed so we can share information about medications, x-rays, and other critical patient care elements electronically. The data information exchange needs to support interoperability. So that's the second set of bullet points in the middle of this slide. It's basically the ability of two or more information systems or software applications to communicate and exchange data. And this is harder than it seems. When I worked for Kaiser Permanente, one of the things that was somewhat problematic to our vaccine researchers were the lot numbers, which is an important data element for vaccine research, was a different field length between the Northern California region and the Southern California region. Therefore, lot numbers from Southern California couldn't be read in Northern California and vice versa. So the way to get around this is to make data interchange standards that support this type of electronic exchange of information. Maybe you fill in the extra characters with leading zeros or leading nines or other have an interface that translate it. They're all different types of ways, and most of these things are really outside of our scope. But it's important to know about the data information exchange, and this is where the rubber meets the road with interoperability. And again, we talked about the HL7, the Institute of Electrical and Electronics Engineers, the people that brought us TCP/IP, and some of these other things. Now we've talked about data and information, but now we need to have a data strategy. And what a data strategy does is it defines our policies, which are guides to thinking, and procedures, which are guides to action, roles, and responsibility. In other words, who will carry out this data governance, and rules. And that way we don't have redundant data that we're paying for. We can manage key master data, and we have the use of structured and unstructured data and the ability to store it and keep it safe. And then, of course, this slide is useful. We talk about data standardization, integration, data quality, in other words, how accurate it is, metadata management, in other words, data about your data modeling, right? So you talk to people, a lot of people were doing data modeling during COVID, data ownership and data stewardship. Who owns the data and who is responsible for the data? And here's the last one, data visualization and presentation. A lot of new exciting tools coming out in data visualization. Some of them you've probably heard of, Power BI, um, Tableau, and others. So this is the ability to take data that's in a numerical format, could be a bar chart, pie chart, and basically put it into a visual so people can understand it easier. And that's all I have for you. Our last video lecture will cover the role of HIM professionals with data management. We'll see you then. Bye now.